So we're going to start in on this. This is called compound inequalities, which we've kind of done. Solving compound inequalities. Girl, stop going across me. Solving compound inequalities. So you already saw a couple of these in your Math Excel homework. But if you see something that looks like this, 3x minus 1 less than or equal to 2 and greater than or equal to negative 13, okay? This is called a compound inequality. You should take some notes, okay? So when I solve this, I solve it just like I'm solving an equation, except instead of doing the same thing to both sides, I do the same thing to all three sides. Okay, so you're solving for the middle. Okay, you're trying to get x by itself. So how do I get x by itself in this case? How do I get this middle? What would be my first step if I'm trying to get x by itself? Add 1. Okay, but I add 1 not just to this side, but I add 1 to the 13 over here. That's a 13, by the way. So I have to do it 3 ways across, right? So I get negative 13 plus 1 makes negative 12, right? And then I get less than or equal to 3x. This goes away, less than or equal to 3. And basically what this means, like in words, is 3x is between negative 12 and 3. What would be my next step if I'm solving this algebraically? Go ahead, man.
Divide by 3.
Divide by 3. Divide by 3, divide by 3, divide by 3. And I get negative 4 less than or equal to x less than or equal to 1. So you just kind of solve that in, just like you're solving equations, if you do the same thing to all three sides. And then you're supposed to graph it. Okay, so you get a number line, you get your number line tool, which you should all have on your Moby boards. You guys don't have Moby boards, okay? And you draw a number line, and less than 1, square bracket or open bracket? Square bracket at 1, and a square bracket at negative 4 over here. And 0 is somewhere in between those two, right? Over here. And then you draw a squiggle to the best of your ability in between those two. So that would be, so this would be the solution. You could write this as I'm just going to, in interval notation, you could write this as negative 4, comma, 1, square bracket. Set builder notation, you would just, set builder notation, you would just write it like this. X bar, like this, and like that, okay? Set builder, interval notation, graphical notation. And that's the intersection between this is kind of like means intersection because it's between those two. Yes? No? We're good? Okay, we're going to do another example. Can I move to another example? Are you still writing? We're good? We're good. Okay, so if they say something like this, which they will, those evil math people, I need a different color. I need some dark blue. Is that dark blue? That's dark blue. Okay. So, oh, that's kind of a purple. So, say I said solve this. 2 minus x is greater than 1, or 4x minus 9 is greater than or equal to 7. Okay? So this is a little bit different. It's telling you to solve two things. but find the solution, kind of combine that solution. So this is like a union, okay? You're finding the union between these two things. Either this, whatever's over here is in this set, or it's in this set. So how do I solve this half of it? What would I do to both sides over here first? Subtract 2. Subtract 2. And I get negative x is greater than negative 1. What do I do to solve that? Tell me what happens when I solve that. What happens when I solve that? Go ahead, Trey. I divide by negative 1. What happens when I divide by negative 1? That's right. What do you get?
X is greater than 1.
Not greater than. What happens when I divide by negative 1?
No, x is less than 1.
X flips, right? So over here I have x is less than 1, right? Now I'm going to go on and solve this one. What do I do to both sides first? Plus 9. Plus 9, so I get 4x greater than or equal to 16. And then what? Then what? Then divide by 4. Divide by 4. So I get x is greater than or equal to 4. So I have two numbers, x's, or two sets that I need to combine on a number line, okay? And it says that x is greater than 4, which you do greater than or equal to 4, so you make a little square bracket there at 4, and you go this way. Or x is less than 1, and you go this way. Oh, curly bracket, right? Curly bracket because it's less than, going that way, okay? And here's 1. And then in set builder notation, you could write it like this. You put an or in between, and you go x bar, and you do this. Okay? Or you can use the union symbol. Okay? In interval notation, this would look like you'd have to break it into two different sets. We would say negative infinity up until 1, not including 1, or you could write the union symbol, or x is greater than 4. Oops, curly bracket. Curly bracket, I mean square bracket. So you go from 4 up to infinity. Who can give me something that is not a solution to this set? Who can give me a number that is not a solution to that set? Go ahead, Chase. 2, right? Because 2 would be in here, right? So 2 is not a number that is either less than 1 or greater than 4, right? Okay? Is negative 100 a solution to that set? Yeah, right? Okay, 2 more, then we'll be done. Can I move on? You need to write that down. Keep going. Are you writing these down? You sure? Okay. All right. Okay. I just want to make sure because. Okay. What if I had? I'm gonna do this one. 4x. Is this the last one? Oh, this is the last one. Oh, yay. And then you can get started on your homework. 1, 2, 3. So say I have 4x. Maybe I should let you guys try this one. 4x plus 2 over 3 greater than 6, or negative 3x minus 1 divided by 2 is less than negative 8. You guys try. You try. I'm not going to give you a whiteboard for this, but I want you guys to give this one a shot and see what you do. So I meant to write down a 2 here. But first you would multiply this equation both sides by 3, right? And you'd get, this disappears and you get 4x plus 2 is greater than 18. And then you would subtract 2 from both sides. Sorry, you guys were looking up here. 4x greater than 16 divided by 4, x is greater than 4. Yes? X is greater than 4. On this side, you multiply first by 2 on both sides. Okay? Sign doesn't flip yet. You get negative 3x minus 1 is less than negative 16. Add 1. You get negative 3x is less than negative 15. Divide by negative 3. When I divide by negative 3, what happens to the sign? It flips, okay? So I get x is greater than 5. Now I want to show you something. When I graph this, right? So a solution to this set can either be greater than 4, if this is 4, or if it can be greater than 5. So where is everything that is either greater than 4 or greater than 5? How could I say that? If you're anything that's greater than 4 or greater than 5. So would 4.5 be a solution to that?
No.
Yes, it would be. Okay? Yes, it would be, right? 4.5, it's either greater than 4 or it's greater than 5. So would 4.1 be a solution to that? Yes. Okay? So you could graph it this way. It's just like this, just a line starting at 4 and going that way. And you could write it, the solution, just as x is greater than 4. Okay? In interval notation, you would just put 4, comma, up to infinity. In set builder notation, you would do x bar, x is greater than 4, bracket here, bracket here. So set builder, interval, graphic notation. All right? Okay. That's it. So you have basically 16 minutes to do some homework. You need to sit here and do some homework and not chat. Okay? What? You have book work and you have Math Excel work. Right? I'm going to write what it is. Homework. Hold on. Page 242, 51 through 63 odd, and then 71 through 77 odd, and then MXL 4-2B, I think it's called. 4-2B, okay? So that's only like 11, 6. That's about 8 problems here, and I think about 8 problems. Not that bad. Okay? Yeah.